Welcome. I'm so glad you're here. My name is Whitney Lee. I'm a CNCF ambassador, and I'm here with Saswata. Saswata, will you introduce yourself, please?
Sure. My name is Saswata Mukherjee. I'm a software engineer based in London and work on the multi-cluster observability team at Red Hat, where I've been employed for about 2.5 years now. So we majorly deal with an operator to enable multi-cluster monitoring using Thanos, and we also run a few instances of Thanos internally at varying scales for different teams to send, store, and query metrics from. And I'm also a maintainer of the Thanos project.
It is such a joy to have you here and to learn from you today. Thank you so much. So Saswata and I just spent almost 2 hours having a long conversation about Thanos, where Saswata taught me so much, and we made this light board together. You're welcome to watch that 2-hour-long conversation. We have a link to it in the description of the video, but we're making a recap resource for you now. So we're going to go over everything that we talked about in the longer conversation. So to start out, Saswata, will you give me some context for what the world was like before Thanos that caused it to get created?
Sure. Prometheus existed and was loved by many. It was widely adopted, but also it had limits. There was no way to scale Prometheus horizontally, no way to query Prometheus across different instances or even dedupe across them. And it was very expensive to use Prometheus to save data long-term and query data long-term, and often impossible.
So then let's start this out really by giving a nice definition of what Thanos is. What is it?
Okay, so Thanos is an open source toolkit of components that is packaged as a single binary and can be composed into a highly available and scalable metrics solution. It can be seamlessly added on top of your existing Prometheus deployments.
That sounds amazing. So Thanos does a lot of different things, and it can be highly customized for your particular use case. And the way you framed this when you taught it to me was very good. So we talked about some things like how it works in Prometheus and then how Thanos improves upon it. So let's go over very briefly the components of Prometheus that we're about to talk about, how we're going to upgrade with Thanos.
So as we mentioned, kind of the components of Prometheus are, broadly speaking, the scraping engine, the query engine, rule evaluation engine, and the storage layer, which we kind of term as the time series database or the TSDB.
Cool. So the first problem in Prometheus without Thanos that we're going to solve with Thanos is the problem of when you have multiple Prometheus instances and you want to query the data that's in all of those instances in one query without having to know which machine that your data is on. So what components does Thanos introduce to help you do that?
Sure. So as you mentioned, the problem of global query view is aggregating data across multiple Promethei. So we have a couple. First is the Thanos query, which is where you will fire your Promethean queries, and it will get data from different Prometheus instances and merge them together for you to view them as a final query result. And we have the Thanos sidebar, which comfortably sits behind or sits beside every single Prometheus instance and reads the data that's in there and then reflects that back to Thanos query using the gRPC store API.
So in this drawing, we have 3 different Prometheus instances, and these queues are like, oh, if you were using only Prometheus, you would have to query each one separately.
Yeah.
But with Thanos query, you query the Thanos query, and then Thanos query can talk to the different Thanos sidecars, which are each running alongside each Prometheus. And then Thanos query figures out where that data is and asks for the data it needs, joins it with the query, and returns it to the user. So that's how those components work together. Thank you for teaching me that. So that solves the problem of querying if the data is relatively new and still being stored in Prometheus itself. First of all, what happens in Prometheus when the data starts to get a little bit older, when it's more than 2 hours old-ish, depending on how it's configured?
So when it's more than 2 hours old, Prometheus will flush that data as a TSDB block onto its disk. And then later on, it might even delete the data once it gets too old.
So when you say TSDB, that means time series database.
Exactly.
And that's the database that runs as part of Prometheus, right?
Yeah.
And so it goes, and then it's stored onto the disk where Prometheus is running. And that's how Prometheus does it. And again, we have that same problem of querying being separate from one another. So how does Thanos act differently behind the scenes when this data is longer term data?
Yeah, so it does this using two components. Basically, Thanos sidecar is going to take that data, the blocks that are on the Prometheus disk, and it will upload it to some object storage bucket. Now, once uploaded there, you need to be able to query that. And that's where Thanos Store Gateway steps in. It reads the object storage, exposes a store API, and Thanos Query can then fetch that data from Thanos Store Gateway to answer your queries, especially your longer-term queries.
So is that longer-term data stored instead of the data stored on disk with Prometheus, or in addition to?
In addition to. So there's some data that's present on the Prometheus disk, but the longer-term data gets uploaded to object storage. And Thanos Query can reach out to both the sidecars as well as the store gateway to compose all of your data in a single place for you to view.
Okay. And then, as we mentioned, how it's expensive to use Prometheus in the longer term, eventually Prometheus will delete that data and it's only available in your object storage.
Object storage, exactly.
So then, so one thing you taught me is that in Prometheus, to do high availability, you might have two Prometheus instances scraping the same data. So now that same data is stored across two different Prometheus instances. Now that, since Thanos has like a global view of everything that's going on, how does Thanos know that when it's duplicated data versus when it's fresh data?
Sure. So you can set external labels on these Prometheus instances to mark them as high available replicate pairs, and then you can tell Query it to look for that label. And so when Query fires a query, it gets data, the same data from each of these high available replicas, and then it will deduplicate that data at query time and only represent you with a full but single representation of that data.
Great. And I guess it's important to say, as we add more and more of these components, just a reminder that these can be composed and used as however you want. You don't have to use all of them. You just use whatever is relevant for your particular use case. So then we talked Thanos Compactor. So in Prometheus, how is data compacted?
Sure.
What does that mean? Yeah.
So essentially, once data gets medium old and is flushed to the disk, you usually get 2-hour blocks. Now, this is fine for a short term, but then over 14 days, that's a lot of blocks that you need to query, and querying becomes slow. So Prometheus will combine these shorter blocks into larger blocks so that querying becomes faster.
And then Thanos Compactor does that exact same thing, but does it as part of your object storage.
Exactly. Yeah.
And then Thanos Compactor also does something else that Prometheus does. Prometheus deletes old data, like you define retention policy within Prometheus, and eventually it deletes old data. And similarly with Thanos Compactor, you can define how old you want your data to be able to get, and at some point you want to delete it. There's a third thing Thanos Compactor does that I'd like for you to describe, and that's about downsampling. How does downsampling work with Thanos Compactor?
Sure. So before explaining downsampling, it's probably best to explain what the problem is, which is when you try and query the long-term data, it's a lot of data. Like every 30 seconds, you have samples, and then across thousands of series, that becomes too much to load into Thanos Query and to your browser. And so what Compactor does is that it will take the old blocks, does it in object storage, and it will downsample them to create blocks that have samples maybe every 5 minutes or maybe every 1 hour. In addition to the raw blocks, it does not remove the raw blocks. And so this way, when you query it long-term data, you fetch the downsample blocks, and thus you load in way less samples, but also get an accurate view of the query that you've had. But yeah.
So way less samples loaded at query time when you're querying for super long-term data. And I don't know if we said this, but if we did, I'll repeat it. If not, it's worth saying that when we're talking about compacting into like 2-hour blocks into 4-hour blocks and like making blocks, all that, the point of doing that is to make it faster to query.
Exactly. Yeah.
Yeah, I'm not sure if we said that, so I'm saying it now.
Sure.
All right, so the final Thanos piece we talked about is called Thanos Receive. So the thing to know about Prometheus is that Prometheus can remote write metric data to remote endpoints. But before we get into Thanos Receive exactly, let's talk about what problem it's solving. What's a good use case for Thanos Receive?
So you might not always have access to the Prometheuses that you need data from, or the Promethei that you need data from. And it might be due to separate teams owning it, or it might be even external people. And so you need to run Thanos often as a service instead of by deploying sidecars, because you don't have access to that particular environment. And that's what Thanos Receive will help you with.
So you can't reach into the environment to pull data. So you need your environment to be able to push data out.
Mm-hmm.
And so in that case, the Prometheus in that area that can't be queried, it's going to use Prometheus to remote write metric data to remote endpoints, and then the remote endpoint being Thanos Receive.
Thanos Receive.
Yeah. So Thanos Receive, it runs as multiple instances across multiple nodes, right? And what does it do? What's an overview of what it does?
So the overview is that once it gets remote write requests, it will ingest that into its local TSDB, which is basically the Prometheus TSDB, but without the other components of Prometheus.
And it can receive from other sources too, you said, not just Prometheus.
Yeah, it can receive any remote write request, whether that be from OpenTelemetry Collector, your own custom Go code that you've written using the Prometheus library, or something else.
Is it also horizontally scalable and highly available, just like Thanos when it's run as a sidecar?
Exactly. It's also horizontally scalable. It uses hash rings. And so you can have multiple Thanos Receive nodes running in tandem with each other and load balancing Thanos remote write requests across each other, as well as replicating data across each other, so that even if one of them is down, you still have full query access. And
so finally, I guess you were saying full query access. Let's talk about how querying works in the Thanos Receive if you're not doing it this way we already talked about.
Yeah, Thanos Receive will also expose store APIs for its local TSDB, so that Thanos Query can reach out to it, fetch data when it gets a PromQL query. And it does it with object storage too. How does does long-term versus short-term data work with Thanos Receive? Yeah, so as you mentioned, Thanos Receive will retain the short-term data on its local TSDB, but it will upload the TSDB blocks to object storage, which then in turn, again, Thanos Store Gateway can discover, and Thanos Query can reach out to it and query both short-term using Thanos Receive and long-term using Thanos Store Gateway. So it seems like a very similar architecture, but instead of instances of Prometheus running, we have different Thanos Receive nodes. Exactly. So is there anything else you'd like to say about Thanos? We covered everything already. I think we missed Thanos Ruler. Oh no, we missed Thanos Ruler. Okay. Aha. Thanos Ruler. Yes. So in Prometheus, you might be using Prometheus for alerting. So maybe you want to be alerted if it's 80% full. So the problem again is that when that alerting happens, it only happens in one instance. It only can use the data from one instance. So we want to be able to have all our different instances of Prometheus work together. And that's where Thanos Ruler comes in. Will you tell us about Thanos Ruler, please? Yeah, sure. So Thanos Ruler uses Thanos Query to evaluate rules and trigger alerts instead of evaluating it locally on the Prometheus level. So thereby you can kind of get a global query view for your rules. So say if you have a rule that says to alert me when all of your Prometheus instances are down or something, you can achieve that with Thanos Ruler. Thanos Query is it keeps coming up over and over again. It's one of the stars of the show. Yeah. I thank you for reminding me about Thanos Ruler, and thank you so much for spending so much time today
teaching about Thanos. It's been such an absolute joy.
Yeah, thanks a lot for inviting me. But yeah.
Yeah, if I'm watching this video and I have questions about Thanos, where should I go next?
Yeah, you should head over on to the CNCF Slack and join our channels, which are Thanos and Thanos Dev. And ask your question or even raise an issue on our GitHub.
Amazing. Well, thank you so much.
Yeah,
Thanks everyone for watching. Goodbye.
Bye.